Hey guys, I welcome you all to BVPIEEE's YouTube channel. Today we have with us Mr. Akash Srivastava. He is a full stack web developer and an intern at Unbiased. In today's session, he is going to explain the underlying concepts of blockchain. If you have any doubts, please post them in the comment section below. So without further ado, let's begin.
So, hey everyone, welcome to the talk on blockchain, the underlying concepts. So, here we have gathered here. So, I am Akash Srivastava. A little bit about me. I am a full stack developer, freelancer, and blockchain enthusiast. I love to engineer and build amazing products. So, that's it about me. So, we are going to cover some concepts about blockchain, and we'll try to do as soon as possible because it is very broad topic. So, we will learn about problem in current solutions, solution provided by Bitcoin and Ethereum, and what is blockchain and underlying working method. And we will also have uh, a live demo session. Okay, so let's get started. So in current solution, as you all know that every operation we have an intermediary to handle the operation like banks for money and online social contact forums for like Facebook and Instagram, and they all deal with the authentication stuff and the stuff we regularly see like validating that person is legit or not. So these stuffs are mainly governed by the central organization. So our first main concern is money, and money is a very broad topic to discuss, but we all know that government regulates the money, so government can inflate the money, and whenever required they can inflate, and this is one of the major cause for inflation in our society, and this is one of major cause for richer becoming rich and poor being poor, and that's all that stuff. Now we move on to privacy. So privacy is everyone's concern here, right? And as you all have already seen that providing data to a single authority, like for example Facebook, can lead to misuse of your private data, and it is we are evident of that particular event, right? So from these examples, uh, you see being dependent on a single authority can cause us big loss in terms of money as well as privacy, and they can do whatever they want to do with our data, and because we are not in control of it. So is there any current solution that is solving any of these problems? Right, we have it. So our first problem was money. So money in current scenario, sending money from one part of the world to another part of the world take several days, right? And but using bitcoin, you have already heard about it. So Bitcoin is a solution that actually Bitcoin is a cryptocurrency built upon a blockchain network for peer-to-peer transfer of money. So it um, eradicates the usage of a single authority like bank to send money from one person to another person in a world. And you can see that in current scenario, sending money from one part of the world to another part of the world takes several days, right? But you can send money instantly using Bitcoin. So there is no need for third party, and there are inbuilt algorithms to verify that person is legit or um, good to go person, and you can send money from one person to other over the world. So our next problem was privacy. So as you all know that uh, a single authority can deal with your private data, but they have in their data system and they can access it, right? So think of an internet with decentralized applications. Decentralized means a single application doesn't residing upon a server, particular server. It reside upon a network of group of uh, interconnected PCs, right? So decentralized applications. 1 second. Okay, right. We'll continue. So where were we? Huh. Decentralized applications. Think of internet where every application is decentralized and it is not governed by single authority. And the system like authorizations are built into the network, right? As you can see, as you see that every site on the internet request your private data to process the but on a blockchain like Ethereum you can have these features inbuilt. So there is no need for this authority to do your authorization stuff. This system is built into the network, right? So from these examples you can see that depending upon single authority can lead to many issues. And all we know that blockchain is a community held technology, right? And all the processing power it gains through the interconnected network of computers, and it have inbuilt payment system, authorization stuff, and much more stuff that is going to develop in future, right? So this is all that we have currently solution we have in our society. Now let's go back to a history, right? So digital timestamp. This term was coined by a group of researchers in 1991, and this is like timestamping the data or digitally and saving it into some system, right, in the form of a chain, sort of. But you see its implementation as Bitcoin in 2009 by Satoshi Nakamoto, an unknown person who don't nobody knows who is. So this is a history about Bitcoin. And now, so you must be wondering that it is able to decentralize the network. So what actually blockchain is? You can simply say that blockchain is a simply a continuously updated record of transactions. And transactions in terms of, you can say, a data that you reside on any server, right? Wait, please, sorry for inconvenience. Okay, so continuing on. So blockchain is a simply continuously updated record on transaction, and it is on a peer-to-peer network without any intermediaries looking to deal with data and logical stuff, right? So this is something very lame about blockchain, and now we will continue we will dig dig deep into it and stuff really deep into what the internal protocol works, how the hashing works, and all that stuff, right? So let's get started with the basic stuff. So in current client server side protocol, you send request to server and in return you get some output, right? And these data are stored on their servers. But on saving on a blockchain is like making a transactions. Okay, so let's start from basic. Like if you want to send money, you need to know the person that he or she is valid or legit person. So in blockchain we use public key, private key, cryptography. You must all be knowing about that public key, private key, and here we have an examples also. So here we have two persons communicating with each other. As you can see in the illustration, widely adopted end-to-end encrypted messaging, right? Here, Bob first writes a message to Alice with saying that send me this amount of money, and the message is gets encrypted using private key of Bob's private key, right? And uh, it is received by Alice, and now Alice can decrypt the message using Bob's public key. So, like private key is held with you, and public key is distributed among your peers. So, in the same way, for every transactions we do, the system adds the private key into the transactions and generates a signature for that particular transactions. Like I cannot generate my signature using anybody else private key. Similar fashion, the system generates the signature using the sender's private key, and that can be verified from other person which is having your public key. So in this way we can verify that transaction is valid and is being sent by a correct person. Now, as we have verified the transactions, let's move on to transactions that is going on throughout the world, and we make a list of transactions like that. Like Bob sends Alice some money, Alice sends to Henry some money, and we have list of transactions here. So this is acting as a block of data, right? Now this block is called a block in a blockchain. So it's quite obvious, I think. And here the transactions are represented as data, which is anything like data into the system. And a block consists of three main things. The first is data, which you are inputting into it, and the second one is hash of previous block. I will cover hash in next slide, okay? And the hash of its own, right? So a block contains many elements, but the major components are these three. So let's continue. So what is SHA-256 hash? It is called simple hash algorithm, which produces 256-bit long string for a particular document, right? So as you can see here, that person is having a fingerprint. In similar scenario, if any document on anything you want to say, any document can have its own fingerprint as a SHA-256 hash. You can say that if you feed anything into the SHA-256 algorithm, it will spit out a 256-bit long string. So it is a string which is which depends on the document you feed into it. If you feed whole operating system or whole video, then it will spit out the 256 long bit. And for every document we have, I let me show you one example here. So I've already told you to go here, and you can find that you can input any data and it spits out this hash. I think this is what we have, and I can feed whole image, whole operating system into it, and it will spit out the hash of 256 long bit. And it is like it will not collide with another hashes like for another data. It is collision free, right? So let's get on to slide. So now we understand the hash. Now let's start building a chain of blocks, right? So let's get started. The first block in any blockchain network is called a genesis block, right? Because from where it gets started. So the genesis block has previous hash as all zeros. You can see here, right? And its own hash. Every block has its own hash, right? Now now more transactions are done throughout the network and new block is created with having the hash of with having a previous block hash and its own hash, as you can see in the illustration. Similarly, as we progress, the links of chain of blocks is created, and you can call it as blockchain, right? This is all what a blockchain name has been provided. Now you must be wondering that how is this tamper proof, because blockchain can never be tampered with by any hacker, right? So how is this tamper proof? So see, if hacker tries to change the block number 3 in the illustration, then the hash of the block totally changes, right? The hash of that particular block totally changes, and which in cost break the link to the next block. And in order to maintain that legit list of blockchain, he now needs to recalculate the hash for next block and then next block until the end of the blockchain, right? This is the way block hacker have worked to do through all the blockchain, and this is quite a heavy task for the hacker, but yet we have powerful computers that can compute thousands of hashes per second, right? We have very powerful computers, so it is not impossible task to compute all the hashes in one go. So to handle this situation, we made the blockchain onto a peer-to-peer distributed network, right? And everyone have the same copy of the chain and are constantly getting updated with new addition of blocks. Like if I added two more blocks here, then it gets broadcasted over the network, and it gets verified that all actually the transactions are verified, and the hashes are verified by other peers also, that the hash calculation is correct. And if it is correct, the consensus protocol say that 51% of the total computing power, if agrees with the block, then it gets added. So if 51% of this whole network agrees with the block, then it gets added to the network, right? So I calculated this hash and broadcasted it into the network. So now if hacker tries to compute all the hashes with more added blocks, then he can broadcast the fraudulent chain. And if everybody agrees with it, then it can lead to devastations, right? So to restrict the calculation of hash for particular time, to restrict the rate of hash calculation, actually, uh, there is most important concept of blockchain called proof of work. So in the next slide I will discuss this. So in common scenario, we were calculating the hash, like a block consists of data and its previous hash, and now we calculate its hash using sort of 56 function, and the output is here, right? This is the normal way we were calculating till now. And in next the proof of work does is quite amazing to say. Like the algorithms say that you need to find the hash string starting with 30 zeros. So how someone can get this string by how someone can get this particular hash string starting with 30 zeros, right? So it's quite impossible. Let me show you illustration. Like if I tap into it, every time the hash is different, and if I delete it one data, then hash totally changes, and again I add it, the hash becomes same. So every time I do it, hash becomes different. So how do I get the first 30 st- uh, first 30 digits as zero? Actually the 30 number is depends upon blockchain, right? So in proof of work protocol, the nonce is like a nonce string that can be added to the blockchain data. So like here, as you can see, I can add this nonce string, a small string that can be added to the network, to the block, that can produce the 30 zeros. And how do I get this nonce? uh, I have to just guess it and estimate it. Like I have just guess it and find the zero. So this is all the stuff miners do, right? They always calculate nonce, and they have rigs of PCs with them that can calculate thousands of hashes per second, and they just do they just guess the nonce string that can be added to the network. Let me show you an example right here to say that how it's being calculated. Like if I have data here and the non-string is here, as you can see here, we were calculating the hash using the transactions list and the previous hash, and here is we have hash. But what proof of work does is it tells you it suggests you, actually it makes you to recalculate the hash by adding nonce to it, right? Like here, this non-string need to be added into the data of the block, and in order to get this nonce we have to guess it and iterate through all the hashes we compute into the and this is all the miners work. Miners just do hash calculations and estimate and guess the block. So actually this is quite amazing and cool concept, because this is suggest that the block has the work is done on the block, and in order to calculate, actually okay, the hashes are calculated like you can see that it is actually proof of work, right? So in previous scenario we were just calculating using previous hash and document, and now we are calculating with nonce. So by guessing nonce there is done of work, like somebody has done work upon that particular block, and this work can, if the hacker wants to recalculate the hash, he needs to go through all this process. And this is quite I can say, like if you have 1 upon probability of guessing that particular nonce is 1 upon 2 to the power 30, because we have 30 zeros in front of it, right? So the probability of guessing that particular nonce is quite less, and it is the miners all over the world compute to calculate this hash, right? I will show you the algorithm here. So here you can see that data and nonce are guessed, the nonce is guessed and data is being input into the hash algorithm, and the hash is being produced. And you can say that difficulty level, like something it's implemented in the network, that if difficulty level of that particular hash is less than the defined difficulty level of the blockchain, then the miner win and he gets to add the block into the blockchain, right? And when he uh, and when he wins, there is some incentives provided by the blockchain to the miner. And this is how bitcoin is being produced, not like government is producing bitcoin, not producing money just randomly without any backing of any type of metals like gold or silver, right? So the work is done on that network, and the winner gets to add the block. And now when the block is broadcasted to the network, does all the miners verify that particular hash is correct, then the everybody does the consensus protocol that 51% agrees with the protocol, agrees with the block, then it gets added to the network, right? If in another scenario that miner was not able to calculate the hash of less than the difficulty level provided, then he need to change the nonce and like guess another nonce, add it to the hash and recalculate it, like like that. So it is quite a process intensive task, computationally intensive. And for and you can say that if a hacker wants to do this changing into the network, then he needs to recalculate this hash and with guess the nonce against it. So this we can say that the work has been done, and it's a proof that work has been done by the guessing of nonce. Let me show you an live example here. You can go to blockchain.com, right? Here's Bitcoin Explorer. So here is list of blocks that is created like mined 11 minutes ago. So it was actually the word for calculating the hash. So this is the hash, right? And it has something like 30 zeros in front of it. And this is called difficulty level. If you want to discuss more about it, you can contact me later on. And where is nonce? Like here you can see the nonce is added to the network. This nonce is responsible for this particular type of hash, right? So by guessing this nonce we say that the work has been done on the network. right? So let's get better onto slide, right? So now you must be guessing that you must be thinking that if you have two blockchains, and like in most scenario this doesn't happen, but if a miner and another miner around the world guesses the nonce at the same time, then the block is added to the network. Yet if for the at the next time the block is then added, and the longest chain among the running chains are chosen for as legit chain, and the another chain is discarded, right? So this is how a robustness of blockchain is maintained. Like if you have multiple chains, then longest chain among the chains are chosen as legit blocks. And in Ethereum, small incentives are provided for the runner blocks, so they do not feel bad about it for calculating the stuff. Actually, the blocks they calculated was legit, but they were late in calculating it, so small incentives were provided to them. And now, based upon the discussions we have done, we can say that blockchain is a distributed and tamper-proof system. So now, there are two types of blockchain, right? Uh, uh, Two actually multiple types of blockchain, but we are discussing Ethereum and Bitcoin here, right? So Bitcoin is defined for particular purpose. So here is structure of Bitcoin versus Ethereum. Wait for a second. Yeah, this whole area is defined for Bitcoin, and this is for Ethereum. So Bitcoin versus Ethereum, right? Bitcoin, on the base level, we have hardware. Okay, but on the base level, we have hardware. Let it, huh. Okay, on the base level, we have hardware, and above that, we have peer-to-peer network. Networking stuff is going on, and operating system like process handling, all that stuff. And above that, the architecture is different for different blockchains. For Bitcoin blockchain protocol, is about the peer-to-peer network, and it is main protocol defined for Bitcoin. And above that we have wallet system or exchange application like transfer of money and all that stuff. In Ethereum, you must be knowing that Ethereum is a blockchain on which you can develop applications, right? So how you can develop application we will discuss further, right, in next slide. uh, Saying that architecture of Ethereum, we have Ethereum blockchain and Ethereum virtual machines running onto the miners or the network all over the network in the world, right? And these virtual machines are running 24 hours all the time. They have blockchain over it. So, and above that, we have application frameworks or smart contracts. We will discuss the smart contracts concept in next slide, right? And and above that, we have end users applications like website or any stuff which you are doing, and which is communicating with the smart contract to get stuff done. And these data which you change, manipulate, or get stored into blockchain, and that is tamper proof, yet your whole data cannot be removed from the blockchain, right? So what is smart contract? It is quite a cool concept, right? You can say that small contract are just a piece of code over the blockchain network, right? And when we want to execute the code, we make a transaction call to the function to execute it. So it's like the smart contracts are piece of codes that is over the network, distributed over the network, and whenever we want to call it, we just make a transaction call to the network, like we were making transaction call for any sending of money, and in turns it the code gets executed, right? And the blockchain network saves the state of that particular smart contract. Like state, you can say that variable names, right, variables and all that stuff which are data related, it saves on the network. In the normal scenario, we save into database like SQLite and SQL, PostgreSQL, MongoDB, and all that. But in this particular blockchain, we are storing that data into the blockchain network, right? So the state of the data is changed. So let's uh, let's have a hands on. So you must be bored with the session, right? So let's get on to making application, simple application onto the network. So go on to Remix Ethereum IDE. You can go here. So by we can get here and make a particular file, like I can say hello.solve. So this is particular file on that our cloud application, right? It's basically a cloud but on blockchain. So you can say that. Now for defining, first we have to say that which version of Solidity code we are using. So Pragma, Solidity. Okay, what? And its version above 0.5.9. It's actually defined, you can see into the documentation, and here we have defined that it says that which version of Solidity we are using, right? And save it. And now we in oops programming, like we have classes. Here we have contract, and contract like hello. Okay, so this contract is acting like a class in a normal programming language, but in Solidity we call it contract. And we define a string public, your name, right? So this is a greeter application, like it greets you when you come to it. So your name is a attribute of this class. And now we add a constructor which is a public. You must be knowing about public concept, right? Your name is equals to none. Currently your name is none. So we have added constructor to this class. Now let's have a function that when we input our name, it assigns the name to the variable and sets it onto the blockchain network that our data has been changed and it is now this particular name rather than being none. Okay. So we have function here, set string, and memory actually tells you about that data is getting at runtime, not already it is not already stored in the network. And name is a variable, public. So here the function set is done, and then your name is assigned with the name we pass. Okay. So let's have another function called greet. It's a view only function, so we will do it like view and public. And in Solidity, when we require to we define that it is returning something, so it return a string, and which is getting from which is returning at runtime. Okay. So here we do return your name. Okay. I think we are done with the code, right? It was quite small code, but yet it is good for understanding the concept. So how do we compile it? Get over here, this particular icon, Solidity compiler, and here is hello.solve, and for compiling it, just tap here, right? and it is compiled. Okay. Now, in order to deploy this particular solidity code onto our blockchain network, Ethereum network, we just go to our this particular icon and tap it, and here you will see deploy button, right? So if you tap it deploy in this screen, like output screen, you can say that we have made a transactions, right? We have made a transaction in order to deploy this particular code onto the network. So this is transaction hash and this contract address, and from this is our address, like it is defined here. You can see this is our address, and to hello dot constructor, right? We have added this constructor, and constructor actually get called when it is executed. And related to gas stuff regarding Ethereum blockchain, you can discuss me later on. Okay, discuss with me, reach out to me. And this is hash of this particular transaction. Okay. Now, how do we communicate with this particular hash? So go here and tap to this particular arrow button, right? Now, as we have here we have set button, greet button, and your name as variable, right? So if you want to set your name, like I want to set my name Akash. So when I tap this particular button, a new transaction has been made. You can see here, and the string name, decoded input string name Akash has been set, right? Now it is onto the network, and the network variable has been saved on the my account address. Now to get the same, like if I want to greet myself, right? So this is greet tab button, and we have made another transaction call here by tapping greet button, and you can see the hello dot greet is called to this address and from our address, right? And here you can see that string Akash is being output, and here is variable. You can tap it and get to know that variable what actually variable stores. So here by tapping it, we then made another transaction call, and the transaction call returns that particular name and hello dot your name. And this is quite cool concept, right? It every time we make transaction, it is getting stored into the network, and every time we made something different, something change, right? Made something change in the variable, it is getting stored onto the network, and it is tamper proof, and nobody can interfere with it, right? So let's get back onto slides. So you must be thinking how blockchain can help, right? So there's term called FITS, FITS. Stands for fraud, I stand for intermediaries, and T stands for throughput, and S stands for stable data. Like F, fraud, where there is chances of fraudulent data or any kind of fraud, like in money, credit, or banking systems, then you can have blockchain there. And where the systems like where intermediaries are required to do anything, and to do anything, like you can say wherever the intermediary is required, then there can be implementation of blockchain. Again, saying that throughput is one of major concern in blockchain, like the hashes calculation rate is slow due to the proof of work, right? So current development is going on in blockchain to improve this throughput, but in current scenario you can deploy your applications which require lesser throughput rate, right? And stable data, like if you want to store any kind of bonds or documents which are not going to change in future, or which are going to change at very long interval of time, then you can have it as a blockchain application, right? So think of a network or internet where the system is interconnected with each other, and Ethereum like system protocol are like operating system operating in low level, right? And over the top we have applications, and these applications are decentralized over the network. And this is quite a cool concept, right, of having to work on IoT data and implementing something which is quite require something stuff like fraudulent data intermediaries. And by eliminating intermediaries, we are taking things on our own hand, and our privacy is not being what do you call that, uh, you understood, right? So thanks for being with me till the end, and you have been a great audience. And you can find me here. um, this is my portfolio. You can find me here. You can talk to me right away, right? Thank you.
I thank our speaker to share his wonderful thoughts with us, and I really appreciate you all for being such a decent audience. With this, we end our today's session. Please like and share our videos, subscribe our channel, and hit the bell icon for more updates. Thank you.